Okay, page 33. Oops. So we've looked at 3 ways to do an inverse. The first two is reverse the coordinate set, reverse the ordered pairs, switch the x, y values, and reflect the graph in the line y is equal to x. These two methods are for graphing. Oh, sorry. If I ask you to find the inverse of a graph, those are 2 choices. You can reflect from the line y is equal to x, or you can just switch the x, y values and graph those. Okay. You would use the last one, obviously, when you're asked for the equation. All right, so that just summarizes what we just did. So normally I would do this page, but we can kind of cover it in the next page. So I'm gonna skip through that. I'm gonna look at some inverse notation here on the next page. So when you have an inverse function, this is how you write it: f to the minus 1 of x. That means the inverse, okay? Whoa, there we go. This is the inverse. So when you see f to the minus 1, it is an inverse. It does not mean, that's an equal sign with a big X through it, that, okay? Because if you remember back to your exponent rules, if you had x to the negative 1, that is equal to 1 over x, right? Is that ringing some bells? Okay, but talking about functional notation, when it's a function, it means the inverse. This is called the reciprocal, and we'll look at that later on. Why is this? Okay, it is not the inverse. If I want you to do a reciprocal, I will write 1 over f of x. If I write f to the minus 1, that is an inverse. You have to remember that. And just to confuse you a little more, they also write the inverses in this form. X is equal to f of y. Which maybe that isn't that confusing, because all they've done is taken y is equal to f of x. And how do you find the inverse? You switch x and y values, right? And that's all they've done. They switch those x and y's into this. So this is an inverse, and this is an inverse. See those forms? If I say find f to the minus 1 of x, I'm saying find the inverse. If I say find x is equal to f of y, I'm saying find the inverse. Okay, they mean the exact same thing. Okay. Let's go down to the bottom here. We'll do a little more algebra. So we don't need to do linear line. Let's do this one here. F of x is equal to x cubed plus 4. I want to find to the minus 1, which is the inverse. So the first thing is rewrite this as y is equal to x cubed plus 4. Because you need to switch the x and y values. Now switch the x, y's. And then solve for y. So move the 4 over. How do I get rid of the y cubed? Cube root it. When you cube root something, do you need to put plus or minus? Not for odd roots, only for even roots. So if I cube root both sides, I get the cube root of x minus 4 is equal to y. which is equal to f to the minus 1. That is your inverse. Are we okay? All right. Next page, please. This will be good practice for your quiz, this part. Okay, we have the function x squared minus 4. Let's graph that. What does that graph look like? I'm going to ask you to do this on your quiz tomorrow, so this will be good practice. What does the graph of x squared minus 4 look like? Which shape is it? The parabola. That's been what? Shifted down 4 units, and it opens. And remember, these go down by 2s, just to confuse you. So that's 2, 4. It opens up. There's your parabola. All right, they want the domain and range. You remember what domain and range are? What is domain? Just in definition of domain. All possible x values. I.e., are there any restrictions on the x values in this function? What are the 2 cases you have restrictions? I told you yesterday. What number can you not divide by? 0. Are we dividing by, is x in the denominator in this case? No. Or what numbers can you not square root? Negatives. Is there a square root in this function? So are there any domain restrictions? No. So what do we write? All real numbers, exactly. So you can write XER, or if you're doing interval notation, negative infinity to positive infinity. Your choice. Okay, looking at, and by the way, all quadratics have a domain of all real numbers. Okay. What is the range? What is the lowest y value here? -4, and then it just goes up, right? So you can say y is greater than or equal to -4, or if you're going to do interval notation, -4 to infinity. Square bracket because it includes the number. All right. B says determine x is equal to f of y. What are they asking for? The inverse, because x is equal to f of y is the inverse. Okay, so we got to find the inverse equation. How do you find the inverse equation? What's the first step? Switch x and y, right? So if I write it at the beginning as y is equal to x squared minus 4. Switch your x, y. Move 4 over. Then what do I do? Square root it, right? Square root both sides. What do you have to remember when you square root? Plus minus root x plus 4 is equal to y. That is your inverse. Let's graph the inverse here. Okay. We can do it with the graph or we can do it with the equation. Which way do you want to do it? Graph? Okay. All right. So this point right here is 0, -2. Where does it move to? It's 0. Here, I'll just write it out. Y. 0, -2 will go to -2, 0. So it's going to go to there. I should do it in a different color. So it'll move to there. This point here is, that is 2, 0. And I have -2, 0. So it is, yep, thank you. I was just testing you. There. 0, -2. So that's a -4. Thank you. There we go. Okay. So it moves to there. 0, 2, and 0, -2. Oh, now I erase everything. Okay, basically here, I'll just sketch the answer. It looks like that. Okay, so all right, can you tell me the domain of the inverse? So looking at the inverse, what is the domain? What is the smallest x value? -4. You're going off my information. So it's -4. It starts at -4, and then they open up that way, right? So we can say x is greater than or equal to -4, or we can say it's -4 to infinity. And what about the range? What can we say about the range? What's the value of the range of this graph? Now, I've drawn them flat. All real numbers, forever and ever in both directions. So we can say YER, or we can say -infinity to +infinity. What do you notice about the domain and range from the original to the inverse? Switch. Just like the XY values switch, the domain, which was all real numbers, has now become the range. And the range in the original, which is greater than -4, has now become the domain in the inverse. So when you do an inverse, the domain and range switch. So I'll write it right here. Domain and range switch during an inverse. Doesn't totally make sense. Inverse. Okay. Is the orange thing, the inverse, a function? No, because if I drew a vertical line, I hit it multiple times. So inverse is a function. And then they're asking, how can you restrict it so that it is a function? what could I do? You'd have to block out either the top bit or the bottom bit, because then you just have this and it only hits it once, or you have this and it only hits it once. Okay, so if restricted to y is greater than or equal to 0, or y is less than or equal to 0. In other words, you've just cut out the top and the bottom. And that's a subtle thing. I won't ask you that on a test or a quiz, but I'm going to be aware. All right. 2 more little things, and then we're done with this lesson. And we got break in 10 minutes, so we should be able to do it. Okay. No, not doing that. Let's do the last one here. Determine f of f to the minus 1 and f to the minus 1 of f. So this goes back to what we did yesterday. What is this little open circle? Like the fog and Gauss stuff we did yesterday. What does that mean you're doing? One function into the other function, right? Opposite functions. So the one on the right goes into the one on the left, right? So what we're really doing in this first one here is we're doing f of f to the minus 1 of x. We're doing that. And for the second one, this guy, we're doing f to the minus 1 of f of x. So in other words, the inverse is going into the original. And this one, the original is going into the inverse. Okay? So first thing we need to do is find the inverse function. Okay, we have f of x is equal to 2x minus 3. So let's find the inverse. How do you find the inverse function? Switch x and y, solve for y. So we'll write y is equal to 2x minus 3. Switch our x and y. There's the inverse. All right, so now we can do the algebra. So f, instead of writing f to the minus 1, we're going to put the inverse in there. So x plus 3 over 2. Whatever's in brackets goes where? In for x. And we're going into the original, so it's going into that x right there. So I get 2 bracket this whole thing minus 3. What happens to those 2's? They cancel each other out because you're multiplying it in. So those are gone. So then I have x plus 3 minus 3, which is just x. Okay. Now let's do the other one. The original function is going to the inverse. Up to the minus 1 of the original, which is 2x minus 3. So the 2x minus 3 goes into the inverse. This is the inverse right here. Into that x there. So I get 2x minus 3 plus 3 over 2. What happens to the 3s? They go away. Then I'm left with x over 2. What happens to the 2s? It doesn't matter what the function is. If you put the inverse, the answer is always x. Always, always, always. Okay? Even if you don't know what the function is. So if I said f of x, you don't have to write this down, is equal to natural log of x. We're doing logs next week. I know you don't know what a log is, but that's okay. And I told you the inverse of that is e to the x. I know that looks like whatever. But, and I said, what is this? You don't even have to do any math. What's the answer? X. Always, always, always. If you put the inverse into the original or the original into the inverse, it's always x. Okay? All right. It's break in a couple minutes. 5, 6, 8A. And then it's break. So I'll give you some time on the other side of the break as well. Why are you not working? Totally forgot to hit play. So, if you FOIL that out, you're going to get 2x squared minus 6x minus 3. Electrolyte terms. Is that what people got? All right. Now we're going to go, we're not going to worry about domain and range. Although, what type of graph is that? Parabola. What is the domain of every single parabola? All real numbers, yes. So I'm just checking. I'm not going to ask you that. We know that it would be x here. Okay, we're not doing range. Calculate the value of FG8 in 2 different ways. So we could go f of 8 times g of 8, or you could just plug it into this function up here, right? Because that is the multiple. So you guys might as well plug it into this and tell me what you get. And I'll do it the long way, and we'll see if we got the same answer. Okay? Did we get 85 for both of those? We do. It's your choice in how you want to do it. I don't care. All right, if you plug it into that or you do this separate f of 8, g of 8, does not matter to me. Okay. All right. 2 more examples. I'll give you a bit more time to work. Okay. Consider the functions f of x is equal to 3 root x minus 2 and g of x is root x minus 5. Write an expression in simplest form for each of the following. F minus g of x. All right, so we're subtracting the functions. So it's f of x, which is that. You have to remember when you're subtracting. Bracket it, yes. What are the like terms here? The root x's, right? So 3 root x minus root x is 2 root x. Negative 2 minus plus 5 is plus 3. And we'll do this one next. Fg of x means we're multiplying them. So this will be good practice of our radicals or review of our radicals from last year. What's root x times root x? X, yeah. So 3 root x times root x is just 3x. 3 root x times negative 5, negative 15 root x. It's 2 root x. 10. And then collecting your like terms is just the middle two terms. Negative 17 root x. And there you go. How would you do these two? What would be the easiest way? I don't know if it's easiest, but just plug it into the equations above, right? Because you've already figured out what f minus g of x is. You might want to put 16 there. This one you've already calculated. F g is 49, so put 49 into all your x's. Any questions about that? It's just a little bit of math. We're going to do the division one after this. So I just need you to please do question number 3, and then we will do the functions. F of x is equal to x squared plus x minus 6 and g of x, x minus 2. Write a simplified expression for f over g of x, including the domain restriction. Okay, So over g of x means f of x over g of x. So write out the functions just like that. F of x is x squared plus x minus 6, and g of x is x minus 2. Just looking at that, we now have a variable in the denominator, right? And if you have a variable in the denominator, you have domain restrictions, okay? So, in other words, what value can x not be? What number can you not divide by? 0. So what makes the bottom 0, the denominator 0? 2. So your domain restriction, right away you just go x cannot equal 2. You got 1 mark for the question. Your people, what is that? So there's your domain restriction. Now we need to simplify it. When you have a quadratic, x squared, and it looks like there's nothing you can do, what should you do? That's what yesterday. Factor quadratics. Okay, so how do we factor this? Well, multiplies a negative 6 and adds to 1. 3 and negative 2. Okay, so the top becomes x plus 3, x minus 2 over x minus 2. Does anything cancel? The x minus 2's cancel. And you're left with x plus 3 with your domain restriction of x cannot equal 2. That is your answer. Later on in this course, we'll learn that that has implications on the graph. It's actually the part that cancels, the x minus 2's. You have an actual hole in the graph at x is equal to 2. Okay, because that point cannot exist. But we'll talk about that later. Right now, all you have to be able to do is factor this, cancel out the expression, or simplify the expression, and write your domain restrictions. If I then said, what is f over g of negative 6? What would be the easiest way to solve that? Plug it in. Plug it into right there, right? So just go negative 6 plus 3, negative 3. You're done. So when you're dealing with division and you have quadratics, always factor. So I'm going to do a couple more examples here. Next page. We're going to simplify these expressions, f over g of x, for the following functions. So the first one, a, f of x over g of x is 2x plus 5 over x plus 5. So right away, what can x not be? Minus 5, because it would make the denominator 0. So there's your domain restriction. X cannot equal negative 5. Can I simplify this expression? The answer is no, even though I know some people out there want to do this. You can only cancel terms, so if they're factored in brackets like this, again, A, B, D, you can cancel B. But if it's just separated by an addition or subtraction sign, you cannot cancel. Okay? So this actually doesn't simplify. You just leave it. You're done. You just write the restriction, and that's it. Walk away. B, x squared minus 2x minus 35. So it's that over x minus 7. What do you do when you don't know what to do with quadratics? Factor it. So what does it factor to? I'll give you a hint. You should always try whatever the bottom is. One of the factors is probably going to be that, x minus 7. So what multiplies 35 and negative 35 and adds to negative 2? Negative 7 and positive 5. It's not always the case, but usually in high school math, they kind of set it up so things will simplify for you. So those cancel. You're left with x plus 5. What is my domain restriction? 7. Even though it cancels out, you still have to include it because it was in the original. Okay? So x cannot equal 7. All right, C. F of x, which is x minus 2 over g of x, squared minus 5x plus 6. You don't know what to do. What do you do? So the denominator turns into x minus 2, x minus 3. Right away, how many restrictions do you have now? You have 2. X cannot be what? Positive 2 and positive 3. There's your restrictions. What cancels? Okay. You cancel everything that's up top. What are you left with? 1. Don't put 0. It's 1. Okay. So the answer is just 1 over. And if everything cancels up top, you can't just write because that is much different than this. So if there's an x minus 3 in the denominator, it stays in the denominator. Okay? Even if everything above it. Yeah. So 1 over x minus 3 is the answer. Restrictions are 2 and 3. All right, last one, slightly different type of factoring, which is why I want to do this one. F of x is 2x squared minus 13x minus 7. And d of x is 2x plus 1. So we write our expression. We go 2x squared minus 13x minus 7 over 2x plus 1. What do you do when you don't know what to do? Factor. All right. Who remembers how to factor these when the leading coefficient is not 1? Now, there's multiple ways to do this. I taught decomp to my class last year. Mr. Oikawa, I think you had him, does a different way. You use boxes or something. Don't care how you do it. I do not care. Just know how to factor these. So the decomp way is you go 2 times negative 7, which is negative 14. And you go, okay, what multiplies to negative 14 and adds to this middle term, which is negative 13? It'd be negative 14 and 1. So the middle term splits up into negative 14x plus x. So that still adds to negative 13. You can use the box method if you remember how to do that. I don't care. I think Ms. Pushka teaches a slightly different way as well. I don't care which way you do. Bracket the first two. What's a common factor of those? 2x. So that's x minus 7. You can take out a 1 of the second two, x minus 7. And the shortcut is these x minus 7s kind of combine together. What you're really doing is factoring them out. So you're left with x minus 7 and 2x plus 1. That's the factored form of the original. On your quiz tomorrow, I won't ask you one where you have to do this because I just taught this on you today. But you should go over that. If you need more practice with those type of things, I can give you more practice. But you need to remember how to do that for later on. So the top of this function is now x minus 7, 2x plus 1 over 2x plus 1. So we can do our restriction. What is the restriction? What makes the denominator 0? If you're not sure, what you can do is take the denominator, 1, and set it equal to 0 and just solve it. So if you move the 1 over, x equals -1/2. That is your domain restriction. So in other words, x is not equal -1/2. There's your domain restriction. What cancels? 2x plus 1s. X minus 7. There's your answer. How's that? All right, it's basically just factor, cancel, write out your domain restrictions. Okay. Number 5, D and E, please. After that, I will